All right, so today we've been sent a stack of sources, all focused on a really specific piece of essential infrastructure hardware.
Mm-hmm.
It's the Thor Broadcast H-STB-QAM-ATSC decoder. Our mission here is to understand why this seemingly small box, which calls itself a unique universal dual standard set-top box,
Right.
why it's still so critical in, large institutional and commercial settings.
It really is the ultimate utility player for any kind of legacy infrastructure. You can think of it as an integrated receiver decoder or an IRD.
An IRD, okay.
Yes, just a fancy term for a crucial converter box. It basically solves this massive headache for buildings and systems that still rely on older cable runs but need to display modern digital content.
So it's a bridge.
Exactly.
Yeah.
It takes that complex digital signal and delivers it to pretty much any display you can imagine, new or old. And it can record too.
Okay, let's look at the input side first, the universal part. That comes from its ability to decode two completely different signal languages.
That's the core of it. You've got ATSC.
Which is the standard for U.S. over-the-air digital broadcasts.
Right. And then you have DVB-C Annex B-QAM 64256. And supporting both is, it's a really big deal.
Why, though? What's the challenge there?
Well, what's fascinating is the engineering. I mean, these two standards use fundamentally different demodulation modes. It's how the signal is packaged and received.
Different languages?
Totally different. For ATSV, it uses 8VSB modulation. For cable, it uses the QAM modes. By supporting both, this device can pull in signals, whether they're coming from an antenna on the roof or from the local cable company's feed.
So it's a translator that speaks two dialects, meaning you don't need two separate boxes.
Precisely. And it's handling modern formats, too.
Yeah.
MPEG-4, HD, H.264, video, but also the older MPEG-2 stuff.
Okay, so that covers the digital decoding.
Right.
But the truly surprising part for me, and I think for you too, was the output versatility.
Oh, absolutely. The output selection is where the real cost savings for institutional users comes into focus. Yes, it has the expected HDMI output.
Up to 1080p 60, standard stuff for any new flat screen.
But then look at what else it offers. YPBPR video output and even CVBS baseband video output.
Wait, can we simplify that? Why would anyone still use those?
So YPBPR is your component video, those three red, green, and blue connectors. Still pretty common on older plasma screens or business monitors.
Okay.
And CVBS is just that old composite video, the single yellow RCA plug. If you have, say, 1,000 rooms in a hotel or 100 classrooms, you can't just replace every single monitor. It's just too expensive.
So this decoder lets those legacy displays keep working with modern content.
Exactly.
But here's the true throwback, and it genuinely surprised me reading the specs: an analog RF out-to-put.
On channel 3 or 4, selectable.
I mean, why would a high-tech decoder in this day and age still need to spit out an old analog signal on channel 3?
Because that's how thousands of existing internally wired distribution systems still operate. Think about hospitals, schools, or military bases with these massive, decades-old closed-circuit TV systems.
Ah, I see.
They get a signal, they modulate it to channel 3 or 4, and then they broadcast it over their existing coax to hundreds of televisions. This decoder lets you inject a new 1080p digital feed right into that ancient infrastructure.
That context makes perfect sense. So we've covered the signal coming in and out, but what about the user experience? Does it have modern features like recording?
It does, and this is where it really becomes a utility box. It's got USB 2.0 PVR functionality for record and playback.
And it's flexible.
Very flexible. It supports all the major file systems, FAT32, FAT16, and NTFS. So you can plug in almost any external hard drive, record content, and then easily move it to a PC for editing or archival.
Plus all the basics, I assume?
Yep. EPG, the electronic program guide, parental guidance locks, support for teletext, all that stuff.
So what this all means for you, the person looking for shortcuts to being well-informed, is that this device is a perfect example of the hidden costs and persistent realities of infrastructure.
Right. It synthesizes multiple digital formats, handles high bitrate video, but its real genius is its maximum compatibility across all this different hardware.
Right down to the little details.
Exactly. Even the standard 75 ohm RF input impedance is a quiet necessity. It just means it plays perfectly with every single coaxial cable standard ever installed in a commercial setting in the U.S.
All right, final thought for you to chew on. If we are truly living in a world defined by digital streams, fiber optics, and instant downloads, why do engineers still dedicate resources to ensuring a device can output legacy analog RF on channel 3 or 4? What crucial, irreplaceable systems are those specific outputs still protecting? And what does that tell us about the real speed of technological adoption in massive institutional environments?